The embedding model did not know what they were when the embedding was generated. We're simply projecting the color on top of it as a way to read it better. And so look at that, like it very, very cleanly actually placed all the gardening stuff in one place, in one area, and the food and the woodworking stuff here. And then of course there's concepts in the middle where if you hover, you say tool for digging and chopping. Yeah, it could be like for, I guess, gardening, could be also for woodworking. A glove right in the middle, could be for any of them, could be for food, could be for gardening, could be for woodworking, right? So, and if you go very far out for baking casseroles, that one for sure is not going to be a gardening or a woodworking tool. So it ends up getting pushed away as the way the model has been trained. And so one last thing about this is that if you were wondering how search works, how do you actually use this as a way to get relevant results, is, well, not only could you say pick a product that you already own or pick a product that you already are looking at and find similar ones. So let's say I say I'm looking for tools that are like gloves. I click on glove here, and it gives me the nearest neighbors around that space, right, in that space, and that allows me to hover over the other one. Let's say protecting clothing. That's kind of closer to glove than, you know, baking casseroles. Wiping hands and mouth, that seems closer than not. Gripping objects, again, it's close enough, could be a reasonable neighbor for it. Protecting the table, you can see a lot of protection stuff going on, right? Now you might be wondering, so that's a way to get, like, you know, the recommendation for the nearest neighbors. You might be wondering, how come the nearest neighbors aren't actually the nearest neighbors? They seem like pretty far away. That's because what I'm doing here, and I didn't mention yet, is I'm reducing the actual complexity that is captured in this model from like 300 dimensions, something like that, down to 2 dimensions, right? So yeah, there's actually that list of numbers that's produced, the vector, is actually 300 numbers or 700 numbers, I forget right now. But I'm just kind of like doing this thing called PCA, which like basically projects stuff down, squeezes it down axis by axis, and all the way to 2D here, which is really killing a lot of information. It is still surprising and quite beautiful that you can still see a bit of a picture of where the things ended up being, even though it's this compressed, the information. And lastly, you can of course take any query that the user wants to actually inject into this. Let's say I'm looking for a new tool for slicing, let's say. Slicing, okay, slicing seems like maybe it's in the woodworking cluster. Tools for slicing vegetables. Now it seems to be in the food cluster, right? So I wanted to do this live demo where as I type, the embedding moves through that vector space, and you can see the nearest neighbors change as well. So slicing vegetables, now we can hover over this one, which is harvesting vegetables, or this one, which is chopping food. So yeah, kind of that's generally what I wanted to